So technically we're picking up in lesson 2.6 where we left off. This is what I had written up here during 5th hour, but let's go back and review a little bit, right? Okay. So we're talking about graphs of rational functions. And we're going to do what we need to do to get these notes done. I've got a few problems here and there I'm going to skip as we go through today. But a rational function being one that can be written in the form of a fraction, f of x over g of x, where f and g are both polynomial functions. On part 1, we're not done with it yet, but we had started talking about finding the domain. And I think you guys remember domain. One of the big things with domain is that the denominator cannot equal 0, right? And you guys kind of led me through that, even in this class. We talked about the fact that if we set x minus 2 equals 0, x cannot equal 2. And if that's where the denominator equals 0, then there is a vertical asymptote at x equals 2. Now, had I drawn the graph in your class? Okay, I had drawn the graph. So this is about exactly where I left off in your class then. Okay. So I drew the graph, vertical asymptote x equals 2. Knowing what I know, I drew in the graph there, okay? Not fully necessarily expecting you guys to just know how to draw that graph, but at least being able to know the vertical asymptote. And then the fact that they ask us to express the domain using limit notation. And this is kind of where this is about as far as I got in your class. But when we talk about this domain using limit notation, okay, so our disruption in the domain is at x equals 2, right? That's where we have this issue. And what we're going to do then is when we talk about it in terms of limits, is we're going to talk, okay, the limit as x approaches 2, what is my graph doing? And we're going to break it up into two pieces. We're going to break it up into the limit as x approaches 2 from the left. So as we travel this graph and we approach 2 from the left, where does our graph go? And the fact that it's going to go down. It's going to go down, which is represented as what in the math world? Negative infinity, right? Then we're also going to talk about, okay, that's as x approaches 2 from the left. We've got a different situation going on as x approaches 2 from the right. And so we'll talk about, okay, as we trace this graph and approach 2 from the right, the graph is going to go up, thus positive infinity. And so those are the two limits we're going to be writing. I'm trying to figure out how I want to. And pretty much what you're going to be doing in homework is writing these limits. So I'm going to write the limit. And practice your notation with me, please. It is important. As x approaches 2 is what that says. Now notice what I'm going to do. On this one, I'm going to put a negative sign after the 2. And what that's saying is as x approaches 2 from the negative values or from the smaller values. So basically, this one is saying as x approaches 2 from the left of f of x equals. So that's your appropriate function notation there. The limit as x approaches 2, and as I said, that negative means from the left. And what's this going to equal? So as I go here, as my graph, as x approaches 2 from the left, where's my graph going? Negative infinity. So that would be half of your answer in relation to the domain, okay, if we're using limits. And I'll come back and put some extra little bits and pieces in here in a moment, some descriptors to help you. The other one, the limit. This time I'm going to say as x approaches 2, but from the right, so now I'm going to put a plus sign on the right side of f of x, so I put the function afterwards, equals. So there's our limit notation there. So as you look at the graph, as x, so as we trace the graph and as we approach 2 from the positive side, where's my graph going? It's going to go up, which is represented as positive infinity. Okay, so to give you a little, first of all, let's see. This right here is, we read this as x approaches 2 from the left is what that reads there. And that's because there's a negative sign there. This one says as x approaches to from the right. And I use left and right, but realize we put a negative sign because it's saying as we approach from the left, or as the negative side, as the values as we approach from smaller values. Positive sign as we approach from the right, as we approach from larger values. Realizing right here, this limit equaled negative infinity because my graph was going down. This limit equaled positive infinity because my graph was going up. Okay, so put those little details, whatever little details you need in there to help you understand these limits. Because that is something as we go along, I'm going to expect you guys to get a hang of this limit notation. Okay. Questions on that part? I'm going to talk a little about one little other thing on this graph too, but kind of understand what we're doing there. Okay, so that was all about domain and relates to vertical asymptotes, which if you look right down below here, we talked about right here, vertical asymptotes where the denominator equals 0. We did that up there. And we're getting ready to do it down here in the next part too. But before we move on from this problem, we're also going to talk about end behavior asymptotes a little bit. So end behavior, anytime you hear me talk about end behavior asymptotes, really what I'm referring to are horizontal asymptotes. Okay, so dig in those brains, dig in the filing cabinets back in your brain. On this example 1, I'm not going to move on from it yet. How do we find the horizontal asymptote? Do you remember?
Down as much as you can on that one, it probably be 0.
Why would it be 0?
Because it doesn't touch.
Well, not in terms of looking at the graph, in terms of looking at the equation. Do you remember how we know about horizontal asymptotes when we look at the equation? The powers? If the powers are the same, if the highest power and top and bottom are the same, we look at those lead coefficients. If the bigger power is on top, there's no horizontal asymptote. And if the bigger power is on bottom, the horizontal asymptote is
0.
Y equals 0. Notice, I drew it in without really talking about it, but did we have a horizontal asymptote here? We did. Okay. It's a horizontal asymptote at y equals 0, so across the x-axis. And notice it's called an end behavior because where the horizontal asymptote really matters is as you go out to infinities, left and right, as you go infinitely out to positive and negative infinity. What's that graph doing? Well, what is this graph doing in this example? It's running alongside that asymptote, and that asymptote has what value? Has a value of 0. And so when you are asked, and I'm going to go ahead and squeeze it right in here. When you're asked to do limits with a horizontal asymptote is, okay, as we go infinitely left and infinitely right, what y value is my graph approaching? So as if I were to extend this graph farther, what y value am I approaching? And in both cases, on the left, I'm running underneath the value of 0 because I'm getting closer and closer to this x-axis from underneath. And the x-axis has a y value of 0. From the right, I'm running above it, but I'm also getting closer and closer to the x-axis, which has a y value of 0. And so when we write these out, we say the limit, and we're going to write them both out as x approaches negative infinity of f of x, and we say the limit as x approaches positive infinity of f of x. And in both cases, and how you usually see me write them, in both cases they're going to equal 0, because they're going to equal what your horizontal asymptote is, which means the book and I will often just write them as equal to each other and equal to the value of the horizontal asymptote. Okay, and again, we're going to do a couple more examples here to help this all make sense. But I'm just trying to help you guys get a grip on these asymptotes here and how we can talk about them with limits here. Okay? So my graph, as it's going off left, as it's going off right, the y value it's getting closer to is that x-axis, which is a y value of 0. I'll show you a different example in a moment that will hopefully help bring some clarity there. Questions at this point? Yes?
So to answer this question, like it doesn't homework, we'd have to have both the horizontal asymptote.
On this one, when we get down to part 2, we'll have to have both. On this one, it just said find the domain. And so I think it would just be the as x approaches the vertical asymptote, so as x approaches that 2 value, because it's in relation to my domain values. Okay. And if I get a chance, hopefully I can glance at the homework and remember exactly how everything goes. Okay. Okay, I don't think, yeah, that's what I say. I'm not ready for that next page yet, am I? Okay, part 2. I'm writing at the bottom of the screen. I'll survive. Now, I will say, I usually just do A and B here, just in terms of time and room. So, part 2 is find the asymptotes of the given equation. When we're talking about finding the asymptotes, I'm talking vertical, horizontal, and we're going to write them all in terms of the limits. Okay? So let's start with A. As we look at A, what thoughts can you tell me just by looking at the graph? Or, excuse me, not the graph, the equation. Okay. Denominator, x cannot equal -3. So that means there's going to be a vertical asymptote at x equals -3. What else do you know?
The biggest powers on bottom, so it'll be y.
Okay, largest power's on bottom, so we have a horizontal asymptote at y equals 0, yes? Okay, I'm going to, let's see, I'm going to sketch a graph for you. And I'm just going to do a small graph over here to the right, or, oh my gosh, left. Don't know my left from my right, sorry guys. And knowing what we just talked about, there's a vertical asymptote at -3, and I'm going to erase and make this a little shorter here. There's a horizontal asymptote at y equals 0. Now, keep in mind, what that means is my graph isn't, I don't have any zeros or anything. My graph isn't crossing these asymptotes. And again, this is more of a, I don't know, because this is a positive fraction, we start this graph from the right on the positive side. And what my graph is going to do is it's going to run alongside, oops, the x-axis, and then when it gets close to -3, it's going to go up alongside that vertical asymptote. A vertical asymptote, unless it has a weird power or anything, a vertical asymptote causes my sign to switch. So right there, my graph ended up positive. When we go over to the other side of this vertical asymptote, we now start off in the negative. And so we're down below that x-axis. Okay, so that's kind of what the graph is going to look like. Now, can you pull this up on your calculator and graph it? Definitely, right? And that's definitely something I would encourage you to check out as we work through this. Okay, so we talked about there's a vertical asymptote at x equals -3, correct? So, in order to express that in limits, kind of like what we did up here earlier. Earlier there was an asymptote at 2. So we did the limit as x approaches 2 from the left and from the right. And that's what we're going to do here in relation to the vertical asymptote. And we're going to have to answer both those. So I'm going to say the limit as x approaches 3, and we're going to go from the left of f of x equals, and then we're also going to do the limit as x approaches 3 from the right.
Should it be -3?
It should be -3. Thank you. Totally overlooked that. Okay, valid, very important point. Okay, so what I wrote there, the first one, the limit as x approaches -3, because that's my vertical asymptote. The negative afterwards says from the left. Then the second one says the limit as x approaches -3 and has a positive after it, and that's saying from the right. And here's the key, guys. If it just says as x approaches -3, it's wanting from both sides, which that means they have to be the same. And in this case, they're not the same. So that's why we have to look at them individually. Okay, do you know how to answer these questions? The limit as x approaches -3 from the left. So that means I'm going to come over here to the left side of my graph, and I'm going to follow my graph, right? Where's my graph going? It's going down, 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 which is equal to -infinity. Then we're looking at x as x approaches -3 from the positive side. So now I'm going to start over on the right side of my graph, and I'm going to follow my graph. As I follow my graph, and we get closer and closer to x equals -3, where's my graph going? Up to positive infinity. We've seen a little bit of how to do that. What other questions that made you come up with them? I'm trying to address everything, but I know I sometimes forget what do I need to think about for you guys that are more beginners with this. So now that was the vertical asymptote, right? We talked about there's a horizontal asymptote, right? Where is there a horizontal asymptote? At y equals 0, because the bigger power is on bottom. Okay, this is chapter 1 review technically. Horizontal asymptote at y equals 0. Now, when we write out our horizontal asymptote limits, your horizontal asymptote limits, here's the shortcut, guys, they're going to equal 0. But what we're writing out is, okay, what's my graph doing horizontally? So as we go infinitely left and as we go infinitely right. So I'm going to say the limit as x approaches -infinity of f of x. We'll come back and answer this in a moment. And the limit as x approaches positive infinity of f of x. Okay. So now, as this time, as x approaches -infinity. So, okay, so think here. As I trace my graph off to the left side, what y value am I approaching?
0.
I'm getting closer and closer to the x-axis, which is a y value of 0, right? That horizontal asymptote of y equals 0. Okay, then as x approaches positive infinity, so as I follow my graph off to the right, what y value am I getting closer and closer to? I'm getting closer and closer to that horizontal asymptote, which is again 0. So what do both of these limits equal? 0. And guys, that's not coincidence. Those limits in relation to that horizontal asymptote, it's in the behavior. What is the graph doing at the ends? Will always equal the same thing, because that's what a horizontal asymptote is going to make us do. Okay? So the limit as x approaches negative infinity is equal to the limit as x approaches positive infinity, which is equal to whatever your horizontal asymptote is. Here, my horizontal asymptote was 0. Questions there? Okay, let's try B. And I'm going to tell you we're not going to get to C, because I still need to look at least at one graph down below, too. And space-wise, I'm going to use all the space for B. Okay. Let's see. Let's talk vertical asymptotes. Can't handle that, sorry. There we go. On B, any vertical asymptotes? Okay, so your denominator equal to 0. X cannot equal 2. So that means there's a vertical asymptote at x equals 2. So what are the two limits I'm going to set up in respect to this? If my vertical asymptote is x equals 2, we're going to set up a limit that says the limit as x approaches 2 from the left. And we're going to set up a limit that says as x approaches 2 from the right. Limit as x approaches 2 from the left of f of x, and the limit as x approaches 2 from the right of f of x. Okay? Now, I haven't graphed this yet for you, have I? Have you graphed it to look at it? I guess I could. Actually, oh, I see where I didn't think I'd put a graph in here, but I did put a graph in here. Okay, I'll come back and graph it here in a moment. Did you guys, I'll graph it before we actually answer these questions. What about horizontal asymptote? Thoughts on what the horizontal asymptote is? What do you notice about the powers? They're both x to the first, so that means they're the same. What's the rule when the highest powers are the same? Leading coefficients, which are 3 over 1. So what's that make my horizontal asymptote? Y equals 3. Now, to be honest, if we have a horizontal asymptote of y equals 3, you can write those limits without ever looking at a graph. Because a horizontal asymptote says, what's my graph going to do as it goes off to the sides? It's going to follow along that horizontal asymptote. Because horizontal asymptotes are in behavior. They follow along. So with the horizontal asymptote, okay, I'm going to write the limit as x approaches, and we're going to look at negative infinity of f of x. And we're going to look at the limit as x approaches positive infinity of f of x. Whoops. Sorry, guys. Okay, so if I sketch a little graph here. What is it? Positive 2 and positive 3. Okay, so we talked about there being a vertical asymptote at x equals 2. We talked about there being a horizontal asymptote at y equals 3. Now, my graph Okay. If you graphed it, did you get like the same two curve things going on? Okay. The difference is this time, I think we start below, don't we? You have a graph that starts below the horizontal asymptote and runs down here. And then flip up, and we have a graph that runs up along here. Is that what your calculator showed you? Should be, right?
Yeah.
Now, here's my question. As you look at that graph, the x equals 2 you could probably figure out, right? Does it make sense that I say there's a horizontal asymptote here? It should, right? As you look at your graph, you're like, oh yeah, there's something going on there. That's where we're at. Okay. We just have to answer these limits if you haven't already. Okay, the limit as x approaches 2 from the left. So that means I'm going to find my graph, and I'm going to come from the left. So I'm going to get on the left side of my graph, and I'm going to come over here. Where's my graph going as we approach 2 from the left? It's going up, yes? And up is positive infinity. Then it says as x approaches 2 from the right, from the positive side. So I'm going to start on the positive side of my graph, the right side, and I'm going to trace this graph. Where's my graph going as we get closer and closer to that asymptote of 2? It's going down. What is down? Negative infinity. Are you seeing how to figure these out? Now, okay, horizontal limits. As x approaches negative infinity. So, as I trace my graph off to the left, what y value is it getting closer and closer to? It's getting closer and closer to the y value of the asymptote of 3. And it's coming from the top side, right? Okay, so that one equals 3. What about as my x approaches positive infinity? So as I go to the right of the graph, as I'm going right, what y value is my graph approaching? It's coming from the underside, but it's getting closer and closer to that horizontal asymptote that is at 3. So what do both of these limits equal? 3. And I should have put those closer together, but the idea, because they're just describing into behavior, they both equal 3. Okay? Yes?
Like, if you were to write it, like, instead of doing, like, the equal sign, you could just put 3 and 3.
You could put 3 and 3. You definitely could put 3 and 3. The only point I'm trying to make while I'm up here in front of you is that it's not coincidence. Yes, they will always equal the same thing. Okay? It's not just coincidence, oh, this one equals 3 this time, this one equals 3, but they won't be the same next time. They will always be the same. Okay, questions there? Question really will be is, will we be able to redo this on homework, right? Okay, give it a try on homework tonight. Okay, let's go down and look at one graph. Okay, so I didn't look at homework this morning to remember, but we're going to talk about what we need to know to graph rational functions. And here's the deal. Yes, you can find all four pieces of these information. And yes, you have some ideas about how to graph these. I'm not expecting perfection that you can fully 100% easily do this without a calculator to kind of double check yourself. But what I want you to do is kind of follow along and learning the pieces, okay? So, there's 4 things we're going to mention. End behavior asymptotes, which what are end behavior asymptotes the same as when we go to graph rational functions? End behavior asymptotes is another way to say horizontal asymptotes, right? And horizontal asymptotes are all about the powers. Vertical asymptotes. How do we find vertical asymptotes? We'll be setting the denominator equal to 0, right? Okay. We also need to know x-intercepts and y-intercepts. In order to find x-intercepts, you're going to set your numerator equal to 0. Because the idea is, for x-intercepts, we want to know when does y equal 0. So when does this function equal 0? And these functions are fractions. When does a fraction equal 0? When the numerator is 0. And so we're looking for when does a fraction equal 0. And then y-intercept is what f of 0 equals. So that is going to be when you put x equals 0 in. Okay? So those are the pieces. And we are going to talk our way through number 2, the middle problem, if you will. Now, as we talk our way through the middle problem, or before we talk our way through the middle problem, let's talk factoring. You always want to factor these rational expressions any way you can. Is there any factoring that can be done on example 2? Here's my hint. There is. I'm rewriting the equation, right? X minus 1 on top stays x minus 1. Nothing to do there. What about x squared minus x minus 6?
X minus 3, x plus 2.
Yep. X minus 3 and x plus 2. That's product and sum, yes. Multiplying to be negative 6 and adding to be negative 1. You guys were pros at that a year ago. I don't know how much you've forgotten since then, but you were pros at it at one point. Okay, so number 1. End behavior asymptotes. Okay, what do you see in the way of end behavior asymptotes? AKA, what about a horizontal asymptote? Are there any? Yeah? Where's the horizontal asymptote at? Y equals 0. And that's at y equals 0 because the... Yeah, if you need the reminder, here it is. Bigger power on bottom. Know those rules for asymptotes. Okay. Step 2, or information 2. We'll put this all in the graph here in a moment. Vertical asymptotes, are there any? There's my hint. There are. I put x equals. Where do we have vertical asymptotes at? 3 and negative 2. Is there a reason I had you factor it earlier? I did. I kind of gave myself away, but I had you factored earlier. So there are vertical asymptotes at 3 and at negative 2. That's your denominator equal to 0. Okay. X-intercepts. Do we have any x-intercepts? Does this ever cross or touch the x-axis? Yeah, x-intercepts are where the numerator equals 0. So where's my numerator going to equal 0? At x equals 1. Because if my numerator is x minus 1, and I set it equal to 0, I'm going to cross the x-axis at x equals 1, which is, if you prefer, is the ordered pair 1, 0. And we need one more item, right? Fourth thing is y-intercepts. What did I say about y-intercepts? It's when x equals 0. So what do you get when you put 0 into this equation? 0 minus 1 is -1. 0 squared minus 0 minus 6. -6. Or maybe you did 0 minus 3 times 0 plus 2. I don't know what you did. But either way, we end up with a y-intercept of 1/6. Or in other words, the ordered pair, 0, 1/6. Okay. You ready? We got to graph it. And I think I have barely enough time. Hopefully I have enough time. Horizontal asymptote, y equals 0. Well, that's just me trying to... There you go. There's your horizontal asymptote, y equals 0. I traced along the x-axis. Vertical asymptotes, -2. So I'm going to go over here to -2. I'm going to put a vertical asymptote. And 3. Okay, vertical asymptote at 3. Piece of cake so far, right? We have an x-intercept at 1. Which means what I like to do to show that is I'm going to put a dot. My graph is going to cross through the x-axis at 1. And yes, you can cross through a horizontal asymptote in the center of the graph. You won't ever cross through a horizontal asymptote that goes off to infinities, but in the center of the graph you can. Okay? And we have a y-intercept of 1/6, which means, I don't know, put a dot in there just above the x-axis, right? Okay, let's graph. This is a positive fraction. This is the part that's a little fuzzy on your part, and that's it. It's a positive fraction. I'm going to start here above the x-axis. As I approach x equals 3, I'm going to run up alongside that vertical asymptote. Then, at the vertical asymptote of 3, I ended positive, so now I'm going to flip down here, and I'm going to start negative. Between this asymptote and the next asymptote, I have 2 points I have to hit, right? I have to cross through, the x-axis at 1, the y-axis at 1/6, and then I run alongside that vertical asymptote. And then we flip again, and now we're down below the x-axis. Sorry, thought I had like another 30 seconds to my credit. Okay, I am mostly concerned about you being able to gather the information, okay? Being able to graph it solely on your own without the calculator, not an issue right now, okay?
Joseph, Eldridge, and Gabe Fowler, please come to the high school office.
Yes, your homework is due tomorrow. Hear that loud and clear. It's due tomorrow because then you'll have nothing over Thanksgiving. Okay? It'll be a pre-calc free Thanksgiving from me. So 2 through 10 evens, 11 through 18 all, and 20 through 30 evens. Let me know as you run into questions.
Have a good day, Mr. Sargent.
Thank you. You too, Craig.